The last example, we have seen some example depend on the orthogonal trajectories of polar form in the polar form. Now let us continue with that, and let us see the next example. R raised to n is equal to a raised to n sine n theta. Call that equation number 1. Now differentiating both sides with respect to theta, that will be our first step. R raised to n derivative is n into r raised to n minus 1. X raised to n derivative should be applied here, and r derivative is dr by d theta is equal to a raised to n is a constant, sin n theta derivative is cos n theta into this n. Take this n earlier because it is a constant. Now cancel out this n on both sides. R raised to n minus 1 dr by d theta upon this cos n theta is equal to a raised to n. Okay, this is the first step, and now second step will be we have to eliminate a raised to n. In this step also you can use log on both sides also. Okay, the other method you can try log of r raised to n is equal to log a raised to n plus log sin n theta. This is some process. Okay, this is n log r is equal to log a raised to n plus log sin n theta. Now differentiate, you will easily eliminate this constant. You will get the same answer. Okay, try this also. Now in this example we are going through other method only. You can go through by this method also, log method. Now put this constant here in this equation, we get 1 becomes r raised to n is equal to a raised to n, that is this term as it is, into sin n theta. Okay, now in this step we are just r raised to n minus 1, splitting out just r raised to n into r raised to minus 1. Okay, now r raised to n on both sides gets cancelled. It becomes r raised to minus 1, take on that side, it becomes r. Okay, sin n theta upon cos n theta become tan n theta dr by d theta as it is. This is a second step complete. Now third step is replacing dr by d theta is equal to minus r square d theta by dr. It becomes r tan theta as it is. This becomes minus r square d theta by dr. Now last step is you have to solve this equation. Okay, arrange the term r on that side, theta on one side. We get this r, 1r gets cancelled. Take r on this side, it becomes 1 by r. Dr on that side, we get dr upon 1 by r minus as it is tan theta and d theta as it is. Okay, now integrating both sides, we get integration of 1 by r is log r is equal to minus as it is integration of tan is log of sec n theta, and divided by derivative of angle should be divided, that is n, plus this c constant, integration constant as it is. Now take this n on that side or multiply both sides by n. We get n into log r is equal to n gets cancelled minus log of sec n theta, and constant into n becomes cn, and constant into constant, n is also constant, it becomes c only. And once we get both the side all the terms as log, you can replace c by log c anytime. Okay, therefore here write down log c. It doesn't matter what constant we are taking, it is according to our adjustments here. Now n comes to the indice, we get log of r raised to n, it becomes log a minus log b, log a upon b, and now both side log gets cancelled, we get r raised to n is equal to c upon sec n theta. Okay, let us see next. R is equal to a theta upon 1 plus theta. Call that equation number 1. Here also you can take log on both sides, we get easily solved. Now we are differentiating with respect to theta. This is one more u by v rule, that's why we are going through the same step. Differentiating with respect to theta, we get our derivative is dr by d theta is equal to a into, this is a constant, a outside, theta upon 1 plus theta is u by v rule we should apply here. v into derivative of theta is 1 minus theta into derivative of v is 1. Again 1 derivative is 0, theta derivative is 1. Okay, divided by in u by v rule, v square is there, 1 plus theta bracket square. Okay, now 1 plus solving the numerator, theta minus theta gets cancelled, a upon 1 plus theta bracket square is there. Okay, therefore by this is the first step completed, that is differentiating the given equation. From there next step will be eliminating the constant. Calculate a constant from this. A becomes this term goes to numerator, we get 1 plus theta square dr by d theta. Put this value in this equation, above equation, we get r is equal to a is this, and theta upon 1 plus theta as it is. Okay, second step complete. We are eliminating the constant. Eliminate the constant. Now 1 plus theta 1 gets cancelled, theta into 1 plus theta dr. Now replacing, third step is replacing dr by d theta is equal to minus r square d theta by dr in this equation. We get r is equal to theta into 1 plus theta, this becomes minus r square d theta upon dr. Now 1 r gets cancelled and take this r on this side, dr on that side, we get 1 by r dr, and this is minus as it is, theta 1 plus theta as it is, and d theta as it is. Once r and theta get separated, integrating both sides, we get log r, integration of 1 by r is log r, theta, multiply this theta inside, what we get, we can write it down, 1 by r integration dr is equal to minus integration of minus theta square d theta plus c. Okay, now minus theta derivative is integration is theta square by 2, theta square integration is theta cube by 3 plus c. Now take on my negative term on that side, we get this answer. Okay, now let us see next example. r raised to n into sine n theta is equal to a raised to n. The constant is on RHS side, that's why by differentiating with respect to theta we get easily eliminate the constant on first step only. Now differentiate with respect to theta, we get r raised to n into sine u into v rule we should apply here, because r raised to n into sine theta, here theta is there, in r also theta, because r is a function of theta, therefore u into v rule should be applied. U into derivative of sine n theta is n cos n theta, plus v into sine n theta into derivative of r raised to n is n into r raised to n minus 1 into r derivative is dr by d theta is equal to a raised to n derivative is 0 because it is constant. Now we are already eliminating the constant, therefore now split this r raised to n minus 1 as r raised to n into r raised to minus 1, and r raised to n throughout gets cancelled, we get, and n also gets cancelled, we get cos n theta plus r raised to minus 1 becomes 1 upon r sin n theta dr by d theta is equal to 0. This is just a simplification. Now third step is replacing dr by d theta is equal to minus r square d theta upon dr. We get cos n theta, it becomes minus, it is r square d theta upon dr, this r as it is, sin n theta as it is equal to 0. Now 1 r get cancelled, cos n theta is equal to, take this on that side, r d theta upon dr sin theta. Now take this cos theta on this side, because theta is in numerator, dr on that side, r on that side, we get 1 upon r dr is equal to sin upon cos d theta. Now once we have the variable separable form, we can integrating. Okay, integrate both sides, we get 1 upon r dr is equal to integration of tan n theta d theta plus c. 1 upon r integration is log r, and tan integration is log of sec n theta divided by n theta, derivative should be divided, that is n. It is the integration rule. plus this c. Take this n on that side. Similarly as earlier, n log r is equal to log of secant theta plus take this c as log c. Okay, n into constant is n is also constant, constant into constant is constant. We can take constant anytime as a log c because everywhere log is there. Now take this n on indice, we get log r raised to n is equal to log of a into b, log a plus log b is log a into b. Now cancel out this log both sides, we get r raised to n is equal to c sec n theta. Okay, now these are some homeworks for you. R raised to n is equal to a raised to n cos n theta. Therefore this is the homework, answer is this. Again this is the another homework, finding out the orthogonal trajectories of this r is equal to a into bracket 1 plus cos theta. Answer is this. Okay, now let us see the last point of the chapter, that is application of ordinary differential equation to the electrical circuit. Okay, before going to the actual examples, let us see what the circuit consists, basic terms in the electrical circuit. Electrical circuit contain a resistor, that is resistance, then capacitance, I is the current, Q is the charge, L is the inductance. Okay, and we know definition of current is rate of change of charge with respect to t is the time, that is I is equal to dq by dt. This is the definition of current. Or Q is nothing but, if you find Q, to cancel out derivative take the integration on both sides with respect to t, we get Q is equal to integration of I with respect to t. These are the basic things in the circuit. Basic current. V is the voltage. V is called voltage or electromotive force. We call it as EMF. Okay, EMF or voltage V. Now let us see some laws of electric circuit. First is Ohm's law. Voltage drop across resistor is given by this is the notation for voltage drop across resistor, which is given by VR is equal to Ri. This is the R into I is the voltage drop across resistor. Now voltage drop across inductor L is VL is equal to L di by dt. Voltage drop across capacitor C is called Vc denoted by Vc is equal to 1 upon C into Q or Q by C. These are the voltage drop across the corresponding elements, that is resistor, inductor and capacitor. These are the basic things. Now let us see the voltage law. The voltage law is algebraic sum of the voltage drop across each element of the circuit is equal to the total applied electromotive force or a voltage. But obvious, if one particular voltage is applied, then current passes through each of this instrument, whether it is resistor or capacitor or inductor. Okay, and therefore some voltage drop should be there across each element, and whatever the voltage drop across each element, if we add all this voltage, that will be the that will equal to the corresponding total EMF or total voltage applied to the circuit. This is called voltage law. Okay, now these are some notes. Note number 1, for maximum charge, in some examples we are using this formula for wherever maximum charge words are there, we have to use this equation. Maximum charge is nothing but dq by dt is equal to 0. For maximum charge, derivative of charge with respect to t must be equal to 0. Q is a charge, I is the current. Now this is the formulas, mathematical formulas, integration formula. We are directly using this. Integration of e raised to ax cos bx dx is equal to, where variable is x, a and b are constant. Formula is e raised to ax upon a square plus b square. A is a exponential coefficient. A cos bx plus reverse the sign and trigonometry. A instead of a, b is there. Cos instead of cos, sin is there. Angle is same. A cos bx plus b sin bx. This is the integration of e raised to ax cos bx. Similarly, integration of e raised to x sin bx dx is, all the terms are same. E raised to b, first term e raised to ax upon a square plus b square. Start with the whatever. If it is cos there, then it start with cos. If it is sin there, then it start with sin. And for sin, middle term is minus. For cos, middle term is plus. A sin bx minus, instead of a, b cos bx. These are the two formulas. Remember one formula, you will automatically arrange the second one by changing the sign. Instead of plus there is minus, instead of cos there is sin everywhere. Okay, and instead of a there is b. These are the important formulas. Rle circuit. There are two circuits where R and E, electromotive force and resistance or resistor is there. Only one circuit contain inductor or capacitor. The Rle circuit means with the circuit which contain resistor, inductor and electromotive force, that is voltage. Such type of electrical circuit has particular differential equation. We have to mug up these two equations. If the in particular example there is only resistor, inductor and a voltage, there is no any capacitor, then the corresponding differential equation of the Rle circuit is given by L di by dt plus Ri is equal to E, where variables are I and T. I means current and variable is T, time. As time is increasing, current also increasing. And Lre, that is inductance, resistance and voltage are the constants, where E is called electromotive force, EMF or voltage. This is the first Rle circuit equation. Now similarly, RCE circuit means where resistor, the circuit which consists of resistor, electromotive force and capacitor. The differential equation of such circuit is given by R dq by dt plus q by c is equal to E, where q is a charge and t is the time. Q, small variables or small alphabets are variables and capital are constants. Okay, RCE is a constant, q and t is the variable. How we decide which is variable, which is constant? It depends on the derivative variables. Wherever derivative terms are there, those variables or those alphabets are only variables, or rest of others are constants. Okay, one more note is there. When time t is equal to 0, when switch is not on, means time is 0, then but obvious charge is also 0 and current is also 0. In every example we are going to use this initial condition. These are called initial conditions. Initial means where time is 0 in the circuit, but obvious if time is 0, then charge and current obviously 0. Now let us start with the example. A 20 ohm resistor is connected in a series. Resistor value is given 20 ohms. Ohm is a unit of resistor with a capacitor of 0.01 farads. Farad is a unit of capacitor or capacitance, and the electromotive force E volt is given by, the value of electromotive force is given by 40 e raised to minus 3t plus 20 e raised to minus 60. This is the value for EMF, that is electromotive force in a circuit. That means circuit consists of resistor, capacitor and EMF. That means this is this circuit. We have to write the differential equation of this circuit as this one in this particular example. Okay, now what is the question? Let us see. If q is equal to 0 at time is equal to 0, means time is equal to 0 but obvious q is 0. It is given in the example. If it is not in if it is not given in the example also, we have to know whether when time is 0 q is 0. Show that we have to show that the maximum charge when charge is maximum on the capacitor is when charge is maximum, then it is 0.25 coulombs. We have to show the maximum charge in the circuit is 0.25 coulombs. Okay, for maximum charge we have to use this condition. Okay, let us see. First we have to write down the differential equation of the RCE circuit. Now we know equation of RCE circuit is given by R dq by dt plus q by c is equal to E. Now what are the given things? R is given 20, C is given 0.01 and E is given this one. Put this value here. We get 20 into dq by dt plus q upon 0.01 is equal to E is equal to this. Now divide all the equation by 20. We get dq by dt plus, by dividing we get 5. 1 upon 20 into 0.01 becomes 5. Q is equal to by dividing 20 it becomes 2 e raised to minus 30 plus e raised to minus 60. And if you observe, this is the linear equation. Instead of y there is q, instead of x there is t. Okay, it is q, here is q, and rest of the example on RHS side a function of t. It is the linear equation. Call that equation number 1. Now we have to solve the equation by linear formula. Now we know p is nothing but coefficient of q, that is 5. Q is RHS side. Okay, now integrating factor is, this is a procedure for linear equation. E raised to p dx instead of dx, that is dt, is equal to e raised to p value is 5. Take 5 constant outside, 1 integration is t. Integration of 1 with respect to t is t. Now solution is, instead of y there is q into integrating factor is equal to integrating factor into q dt. Instead of x there is t plus c. Put this value. Q into integrating factor is this plus is equal to integrating factor is this into q is total this term into dt plus c. Now take this e raised to 5t inside, it becomes q into e raised to 5t is equal to integration of 2 e raised to 2t plus e raised to minus t. Indice is same, indice base is same, that's why indice get add or subtract. Dt plus c. Now take the integration of e raised to 2t is e raised to 2t by 2, e raised to minus t is e raised to minus t upon minus 1 plus c as it is. Now 2 gets cancelled. Q e raised to 5t is equal to e raised to 2t minus, take this minus middle, e raised to minus t plus c. Call that equation number 2. Now in this application point, we have to find out the integration constant c. In earlier examples, we are not finding the integration constant because we don't know what is x and what is y. But in this particular example, we know what is q, this is a charge, what is t, this is a time. And we know the initial condition, when time is 0, q is 0. These conditions, initial conditions, are generally used to find out the integration constant c. Okay, it is already given in the example. If it is not given in the example also, you have to write down this equation here. At time t is equal to 0, q is equal to 0. Put this value, 2 value here, we get q is equal to 0, therefore 0 is equal to e raised to t value 0, e raised to 0 is 1, again e raised to minus 0, that is 0 is again 1, middle sign is minus 1 minus 1 is 0, therefore c value becomes 0. Put this value in this equation, that is our solution. We get q e raised to 5t is equal to e raised to 2t minus e raised to t. Call that equation number 3. Or just take e raised to 5t to on that side, divide by e raised to 5t. We get q is equal to this divided by e raised to 5t. Now again separate out this. We get q is equal to e raised to 5t becomes minus 5t, plus 2t becomes minus 3t, minus e raised to minus t, e raised to minus 5t becomes e raised to minus 6t. Call that equation number 4. Okay, now we have to find out the maximum charge. For maximum charge, we have to find out value of q charge, that we have to show it is 0.25 coulombs. Okay, now we know the theory part. For maximum charge, dq by dt is equal to 0. That means derivative of q with respect to t, it becomes 0. Now we get q only. For dq by dt means derivative, we have to differentiate this equation with respect to t. Our next step will be for maximum charge, that is q maximum. We call it as q maximum. Our final answer will be q maximum, and answer is 0.25. We have to show. Now differentiate given equation with respect to t. It becomes dq by dt is equal to e raised to minus 3, derivative is e raised to minus 3 into minus 3. Minus, as it is e raised to minus 60, derivative is e raised to minus t into minus 60, minus 6. Take minus minus, this becomes plus, this becomes minus 3 e raised to minus 3t. Now from this equation, from star, call this star or 5, anything, dq by dt is equal to 0 implies this term is equal to 0. For this we have to solve this equation. Now this 6 e raised to minus 6t becomes, this becomes plus 3 e raised to minus 3t. Now take this e raised to minus 3t here and 6 on that side. We get e raised to minus 6t upon e raised to minus 3t is equal to 3 upon 6. Now take this e raised to minus 3t on numerator. We get e raised to minus 3t minus 6 plus 3 minus 3 is equal to 3 by 6 is 1 by 2. Okay, now put this value in our final solution 4. This is our solution. We get q maximum, means after finding this dq by dt is equal to 0, q becomes q maximum is equal to e raised to minus 3t minus e raised to minus 60 becomes e raised to minus 3t. We have only one value, e raised to minus 3t, and e raised to minus 60 is nothing but e raised to minus 3t its square. Index raised to index becomes 3 to the 6. Okay, now put this value of e raised to minus 3t here. We get 1 by 2 minus 1 by 2 square. 1 by 2 minus 1 by 4, it becomes 1 by 4, and value of 1 by 4 is 0.25. Final answer is q maximum. Maximum charge in the circuit is 0.25. Unit of charge is coulomb. Okay, remember those. Unit of resistors is ohm, unit of capacitor is farad, unit of current is I, ampere, unit of charge is coulomb. Okay, okay, now let us move to other example.